Today we're taking another step into section 10.3. We've done the sequences, we talked about the geometric means. Today we're finally getting into the series. What is a series? The sum of a sequence. A sequence is a list of numbers with pattern. A series just adds up that entire list. If it's a geometric series, guess what you know about the list? That sequence that it's adding up. Don't overthink it. It's a geometric series. The list that got added up was so we're going to be adding to our formulas. Today we're getting into our geometric series formulas. Now, these formulas are not quite as intuitive as the arithmetic ones. That's why I didn't give them to you before. Okay. S sub n is equal to. Now, the first formula I am going to give you is the way the book treats this formula. It goes a sub 1 minus a sub 1 times r to the power of n all over 1 minus r. I personally find that this format of a series formula actually causes some issues because of that a sub 1 being in two places. And oftentimes what we are wanting to do is work with this formula and be able to get a sub 1 out of it. So I find that it's easier to rearrange this equation. To factor out the a sub 1, multiplying it by 1 minus r to the power of n all over 1 minus r. I personally ignore that formula. Is it true? Yes. Will you see it sometimes? Sure. Am I really going to use it? No. There's also S sub n is equal to a sub 1 minus a sub n times r all over 1 minus r. Now, when it comes to your sequences and series, one of the things that's a good idea, I want to give you a good look at all of these formulas together. You will notice some things in common amongst them. Sequence formulas, whether it be arithmetic or geometric, always start with a sub n. Series formulas always start with s sub n. And the other thing, there is something every single geometric formula, sequence and series, has in common, and that is r. Most of the arithmetic have D, but there's an exception to that rule. So, if you want to differentiate between these formulas, if I just gave all of these formulas to you without labeling them, you could tell what's a sequence versus what's a series by looking for a sub n equals versus s sub n equals. And you could tell if it is arithmetic or geometric by does it have an r, because geometric all have r. Do you think that maybe at some point I'm going to maybe have all of them together without labels? And that might be why I'm telling you this. Think again. On our next quiz, I'm going to give you all the formulas, but I'm not telling you what is what.
Why? Why can't you just tell us? So Tuesday we have to have
So, when it comes to these problems, being able to differentiate between arithmetic and geometric, both in the formulas and in the problems themselves, is key. Same with, is it a sequence, is it a series? Is this arithmetic or geometric? It is geometric. How do you know that? From term to term, it's multiplying by 3. Is this a sequence or a series? How do you know? Plus, 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 find the sum. All series references. I gave you 2 formulas, technically 3 formulas, for the sum of a geometric series. Both of them require knowing what a sub 1 is. What is a sub 1? 2. Both of them require knowing what r is. What's r? 3. One of them requires knowing what n is. The other one requires knowing what a sub n is. What are n and a sub n in reference to sequences and series? Go for it.
N is how many terms over you have to do, like use. A of n is the very last term
But kind of. N is how many terms over you need to go. It's the position of the term. A sub n, it's not always the last one. That's why I'm like, eh. But a sub n is the number in the list in the nth spot. Oftentimes the last spot. For series, it's generally the last one you want to add together. Do we know either n or a sub n in this situation? Ellie? 10 is what? Is it the position of the terms that I'm adding, or is it the last term I'm adding? It's the position. N is 10. The number of terms you're adding is tells you how many positions you're adding up. Hence, N. Okay. Which formula am I going to use? The top one. The top one's the one that involves n. So it says a sub 1, 2, parentheses, 1 minus r, 3, to the power of n. Make sure that power is going to the right spot. Does it go in the parentheses or outside the parentheses? Inside. It's a common mistake. All over 1 minus r. Is this a calculator friendly equation? Can I just type this entire thing in? Yes-ish. Thank you. Where do I need to put parentheses to make this truly calculator friendly? Around the 1 minus 3 on the bottom. And if r is either a fraction or negative, it needs parentheses before the power of 10. Otherwise, beyond that set of parentheses here, I can just type this in. $59,048. Seems awfully large, doesn't it? Does it seem too large? The first 3 terms added together might make that seem a little too large, but if we think about it, we're continuing to multiply by 3 from term to term. Aren't my numbers getting pretty big pretty quick? So, it's perfectly fine that that's a little obnoxious in size. Okay? What?
You asked for the first 10
It wants the sum of the first 10 terms. Always should be starting these problems with 2 questions. The first question. I'm calling out the same names. I'm shuffling this again. Because I seem to call Carly every single day I grab these. And then some of y'all never get called up. Danielle, is this arithmetic or geometric? Geometric, because from term to term it is dividing by 3. Della, is it a sequence or a series? How do you know it's a series? I agree with you. Or did you take a 50-50 shot? Yes, because the directions say find the sum. It's listed as a sequence, but if I'm asking you to add it all up, that makes it a series. Okay. So I got these formulas. Veda, what's a sub 1?
27.
Sam, what's R? Where do you get 1/3 from? Dividing by 3. R is what you multiply by. To divide by something is to multiply by its reciprocal. Good catch on that. Ruby, do I know N or do I know A sub N? And what is N? N is 7. Aubrey, if that's the case, am I using the first formula or the second one?
First one.
I'm using the first one again. So, a sub 1 is 27, R is 1/3, N is 7, all over 1 minus R. Jack, if I want to make that calculator friendly, what do I need to do? Is that the only thing that needs to go in parentheses? What on top? Well, yeah. I meant additional parentheses. Do I need to add any additional? It is a really good question, Alex. What are you thinking? Around, not the negative 1/3, because it's not negative, it's just 1/3. Anytime R is a negative or a fraction, it needs parentheses. Wendy, what do you get? For the whole thing. Because I would put the whole thing into my calculator. Question or answer? She's getting it. She's giving her a minute. She's got that. How long would we be writing 481? If it's a repeating decimal, what should we know about it? can be written as a fraction. Here's the thing. Can I write this down without having to round it? Yep, I could write it like that. But I can also write it as a fraction. Do I prefer fractions? Absolutely. If you can write it down as a decimal without having to round, that's fine too. If your calculator doesn't change it into a fraction, that probably means something's wrong with not necessarily your math, but you probably just can't. -4, 8, -6, ... -4,096. Arithmetic or geometric? I agree with you, but why? Because from term to term, it's always multiplying by -2. Sequence or series? Why? It says find the sum. My instructions are still to add them all up. Isaiah, what's a sub 1? Braylon, what's R? Kylie, Greener. Do I know a sub n or do I know n this time? How do you know that? It gives you the last number it wants you to add, which is a sub n. Which means we're not using the first equation anymore, because the first equation requires n. We're using the second. -4 minus -4,096 times -2 all over 1 minus -2. This can be very calculator friendly as well. If I put parentheses, where do I need them? Up there somewhere? Perfect. Can you get a little more specific? Around the negatives. You can, but you actually don't this time need it because there's not an exponent on it. Alex?
Around 1 minus -2.
Around 1 minus -2 around the denominator. Anywhere else? Around the numerator. You cannot put an ugly fraction into your calculator without having parentheses on top and bottom. The reason we didn't on this one is it already had the parentheses. Yeah, the 27 on this example was outside, but 27 out here versus 27 on top of a fraction do the exact same thing. Hence, I don't need additional. That needs them. Hannah, what do you get? -2,732. Word problems will come up quite a bit in this section. Pendulum swings 20% the distance of its previous swing. If it started at an 80 centimeter swing, the first question I'm going to ask in regards to this is how far does it swing on the 7th swing? Any thoughts on how we can determine if it's arithmetic or geometric? How do we normally determine arithmetic or geometric? We look for if it is adding the same amount or multiplying by the same amount. How do you find percentages of things? Fraction. And do you multiply by the fraction or add the fraction? You multiply by it. So is this arithmetic or geometric? Overall, the problem is geometric. But if it is a sequence or a series is going to depend upon the question itself. How far does it swing on the 7th swing? Does it mention anything about adding up the swings? No. It asks about an individual point in time, which would make it a sequence. For geometric sequences, we have this formula. A sub n. Do we know it, or is that what we're looking for? We're looking for a sub n. A sub 1, do we know that? 80 tells us that at the beginning. Times. R, do we know that? What are you multiplying by to get 20% of something? 20 over 100, also known as 1/5, also known as 0.2. I don't care which form you put it in. I personally prefer 0.2. To the power of n minus 1. Do we know what n is? I heard it. This is n. 7 minus 1 happens to be 6. .00512. Here's the thing. Not only can I write this without having to round, it's a word problem. If someone came to you and said it swings this length and that length was a fraction, wouldn't for the most part you give them a weird look? It swings 700. What would this one be? It swings 16 out of 3,125 fifth centimeters. Yet no. Word problems, give me decimals. Reasonably round. How far did it travel in 7 swings? What did I change about the problem? Anyone?
You're asking how far it traveled now, so
Now we're adding all the swings up. Now it wants all of it. So this is now a series. A sub 1 is still 80. R is still 0.2. N, they kept as 7, that could change, divided by 1 minus R. Make that calculator friendly. I remember to put parentheses here. .99872 centimeters. On a word problem, would I technically need that many decimal places? Probably not. Since I can write the entire thing without rounding, I just do.